Okay, in this lesson we're going to do the product rule. Again, in during the class, I've already talked about the product rule. I hope you guys already remember the formula. So I'm just going to have a recap of what is a product rule and how do we use it, and then what is sort of like a shortcut to do the questions without using the proper formal formula. All right, so we use the product rule when we have a product between 2 or 3 or 4 different functions. And in order for us to differentiate it, we need to use the proper method to differentiate it. So it's like, when you have y equals to u times by v, you've got a product of 2 different functions. The product rule says you have to differentiate one function at a time, and then you times by the other function, and you find the sum of those 2 products together. All right, so the formula tells you that dy over dx is equal to, now you first differentiate the first function, all right, so you differentiate the u first, and that gives you the du over dx, and then you times by the original of the second function, which is v, plus, then you differentiate the second function, which is dv over dx, and then you times by u. Okay, so that is what a product rule is. I think some textbook actually shows you can use the cross multiplication to do the product rule question, which is fine if you're happy with that. So I'll show you an example where you actually use the formula to do the product rule. So I'm probably just going to pick an elementary question. Let's see. All right, so something like this, pretty easy, straightforward, like not this one, not those questions here. All right, so like this one here, x to the power 3, x plus 1 to the power 4. So example 1. So if we have y equals to x to the power 3, x plus 1 to the power 4. You can use this method. I don't, I'm not going to force you to use the way I do the questions. I just don't like to write on a u and a v. So you can use this method. You can say let u equals to x to the power 3. You can let v equals to x plus 1 to the power 4. Then you can find u dash, v dash, which is 3x squared. And that one is just equal to 4x plus 1 to the power 3. Now once you finish that, then what you can do is you can cross multiply like that. And that becomes the product rule because, as you can see here, you've got the original function u times by the derivative of v. Then you have the original function of v times by the derivative of u, which is exactly the formula up here. All right. So yeah, well, in that case, the product rule tells you that the y over dx is equal to the cross multiply. So it becomes 4x to the power 3, x plus 1 to the power 3, plus 3x squared, x plus 1 to the power 4. Okay, usually for the product rule question, usually you need to factorize it. Okay, usually factorize until you can't factorize any further. Okay, so that gives you 4x plus 3x plus 1. All right, so at the end, the final answer is x to the power 2, x plus 1 to the power 3, and then 7x plus 3. Okay, that becomes the answer for this question. This becomes the working out to show where you're using the product rule to get to the final answer there. All right, now I would like also to show you another way to do this question without, I'm still using the product rule, but without really writing the u and v, u dash v dash out. You sort of just do the question, in your head. I believe it's more efficient, but obviously when you first start to do it, it's easier to make silly mistakes. So, choose the correct, choose the best method you like to use to do the product rule. All right. So for this question here, what I will do is I'll sort of know that this is my first function. That's my second function here. So all I need to do is if I want to find dy over dx, I am going to differentiate that function first. So I'll remind myself, I'm going to differentiate this function, which that gives you 6x plus 1 to the power of 2. Once you finish that, I need to, times this one over. So that gives me x plus 2 to the power 4. That becomes the original. So it's like, this is u dash, and that's v. Then I remember, okay, next I need to differentiate that function here. All right, which is 4x plus 2 to the power 3. And obviously I need to times by the function for u, which is, in that case, 2x plus 1 to the power 3. All right, so I'm still using the formula however, instead of writing the u and u dash v dash out, I'm just doing everything in my head. So that gives me v dash, and that's u. So I'm still using the product rule. All right, again, you still have to simplify it, factorize where it is possible, before you get the final answer there. All right, just be very careful about the factorization. Take the highest common factor out. That becomes 2 x plus 1 to the power of 2 x plus 2 to the power of 3. All right. Okay, so that gives you 2x plus 1 square, x plus 2 to the power of 3, and that's 7x plus that's 6, that's 4 plus 10, I think. Okay. All right, so that should be the answer for this question. All right. Feel free to use any method that you like to use. You can either use the first method here by writing the u dash v dash, or you can just do the question by thinking about this is u, that's v, and you just continue with the process. All right, so let's now try a few questions from the exercise. Again, I'll try those like application type. All right, so let's have a look. Question 8 looks pretty interesting. So let's have a look at question 8. The question says, show that the function y equals to x to the power 3, 1 minus x to the power 5 has a horizontal tangent, which means the gradient is equal to 0, with x coordinate equal to 3 over 8. And then show y coordinate of p is equal to that expression there. Okay. All right, so let's start. That's question 8. All right, so I'm just going to write down the function here. So y equal to x to the power 3, y minus x to the power 5. And then we need to show that it has a horizontal tangent at point P. So the point P will have x coordinate of 3 over 8 and a y coordinate missing. We just need to show that y coordinate is equal to 3 to the power 3 times by 5 to the power 5 over 2 to the power 24. Very interesting. Let's have a look. All right, let's start. So the first step, we need to find the derivative, okay? So we need to use the product rule. Now, please remember, that's the first function, that is the second function. So we're going to differentiate the first function, 3x squared, copy the second function down, plus, now you differentiate the second function to the power 4. Now be very careful, you also need to times by -1 here, just because that is also a chain rule. So the derivative of what's inside is -1. Then you times by x to the power 3. All right. Now we just need to simplify it. Minus x to the power 3, or actually 5, 1 minus x to the power 4. Okay, all right. So we got to this point. Now we just need to show when x is equal to 3 on 8, it gives us a horizontal tangent. You can either solve this equation to find the value of x, or you can just substitute. I feel like, they asked us to show how the horizontal tangent at point P. Okay, so we can substitute. Sub x equal to 3 over 8 into dy over dx. We basically need to show that dy over dx is equal to 0, so that becomes a horizontal tangent. So the tangent is horizontal, where the gradient is equal to 0. All right, okay, so that gives us 3 times by 3 over 8 to the power of 2, 1 minus 3 over 8 to the power of 5, so to the power of 8 to the power of 3 to the power of 4. Okay. All right, if you have a calculator with you, then you can use your calculator. I would try to do this one without a calculator to see if I can do it. That is 5 to the power of 8 to the power of 5 and a 5 minus 3 times by 3 to the power of 3, 8 to the power of 3. That's 5 to the power of 8. That's 4 and a 4. Okay. All right. What should I do here? Looks like I probably need to use a calculator. Yep. I'll use a calculator this time. Alright, hopefully this is equal to 0. I feel like, there's another way you can do this question without using a calculator. But instead of wasting time, I'm just going to use it. 5 over 8 to the power of 5. Alright. Minus. Okay, so that is equal to 0. You can also confirm with the answer, all right, to actually see if that's equal to 0 or not. But I feel like there's another, like, yeah, well, you can use this method by just substituting, the numbers inside. But alternatively, what you can also do is you can solve this equation. Okay, so like solve this equation. Since we know that's a horizontal tangent, we can let that equal to 0, and hopefully you can actually find out the answer. X is equal to the numbers that you need, which is 3 over 8. All right, so if we solve this equation, that becomes, we need to factorize x squared, y minus x to the power of 1 outside. That gives you 3, oh, actually 4. That gives you 3, y minus x, minus 5x is equal to 0. So you will have a multiple points where the curve will have a horizontal tangent, where, you will have a multiple stationary point, which we will talk about later. So if we let this equal to 0, so x equal to 0, we let this term equal to 0, x equal to 1, we can also let that part is equal to 0, so that gives us 3 minus 3x, minus 5x is equal to 0, negative 8x is equal to minus 3, x is equal to 3 over 8. So I feel like, it's actually easier to solve the equation instead of just substitute this number inside to prove the gradient is equal to 0. Okay, so you actually let the gradient equal to 0, you solve it, and you find out that the x is equal to 3 over 8. Okay, now we need to show the y-coordinate of point P is equal to that expression there. Now, to find a y-coordinate is actually pretty easy. You substitute 3 over 8 back into here, then you should be able to find the y-coordinate. That's not a really hard question there. All right, so let's start on this side. Y is equal to 3 over 8 to the power of 3, y minus 3 over 8 to the power of 5. And that gives us 3 to the power of 3 over 8 to the power of 3, times by 5 to the power of 8, 5 over 8, and that's 5 to the power of 5, and that's 8 to the power of 5. Well, at the end, we need to show this is equal to that. So we need to use our index law. All right, so what we need to do is change the denominator to 2. Looks like the denominator is in terms of 2, yes. So we change the denominator in terms of 2. 2 to the power of 3, and there's another power of 3 here. That's 2 to the power of 3 with the power of 5. Numerator is equal, it's fine, so we just leave the numerator. So now the denominator becomes 2 to the power of 9, and then 2 to the power of 15. That's 3 to the power of 3, that's 5 to the power of 5. So if you times across, that becomes 3 to the power of 3 times by 5 to the power of 5 over 2 to the power of 24, which is the answer we need. And that's just using the, simply just using the indices. Okay, so that's question 8, which we are using the product rule to actually solve the question. All right, so it's not that hard for this question. Feel like maybe we can try something that's slightly harder here. So let's have a look at this question. Which one should I do? Okay. Oh yeah, okay, question 14. The enrichment question here. All right, so we'll do question 14. It's pretty interesting so this is question where you have 3 products, all right? And then you have 3 terms, 3 factors, and when they times together, and how do you differentiate it? All right, so y is equal to, I'll do x to the power of 5, the first one, all right? So 14a, x minus 1 to the power of 4, x minus 2 to the power of 3. All right, so how do we differentiate that? Unfortunately, for a question like this one, you don't really have a shortcut, okay? Some people try to combine them. Yeah, don't do that. Terrible idea. Just don't. So, don't expand. Just don't. All right, you're gonna have a crazy times if you expand it. So what are you going to do here is you are going to do a product rule multiple times. So it's like you need to do something like this. So you're gonna group it. You can either group the first two or the last two. It's up to you. Once you group these, then now what I suggest you to actually letting U to be the terms like this. And you let V equals to the second term. And then you start to find out V dash and U dash. Oh, oops, that's V, not V dash. All right, so U dash, it becomes another product rule. Okay, so for this one, it's actually pretty easy. You can do it without writing U and V again. But if you do want to use it using V and U, please do use any other letters using A and B. Okay, don't use U and V again. All right, so x to the power 5. All right, so that's U dash. Okay, I still want to factorize. So it's clear and easy. That's 5, x minus 1 plus 4x, which gives me x to the power 4, x minus 1 to the power 3, and then 5x, which is 9x minus 5. All right, so that becomes U dash. On this side, V dash is 3x minus 2 to the power 2. So that's pretty easy. So now you have 4 terms, right? So 1, 2, 3, and 4. And these 4 terms, you can just do the product rule. And these 2 times together, and these 2 times together, all right, to give you the final answer. So therefore, dy over dx is equal to x to the power 5, x minus 1 to the power 4, times by 3, x minus 2 to the power 2, plus x minus 2 to the power 3, and you times by every terms you have for the U dash. Okay, all right. Once you get to this point, looks like we can still further factorize. We do have some common factors here, so I'll show you. X to the power 4 and 5, you got a common factor here. X minus 1 to the power 4, x minus 1 to the power 3, that's also a common factor. There's one more, which is the, x minus 2 and x minus 2. All right, so factorize. X to the power 4 out, x minus 1 to the power 3, x minus 2 to the power of 2. All right, let's see. That's x minus 1. Oh, I need to have a 3 here as well. Plus, what do I need to do here? Okay, x minus 2, and the last one is 9x minus 5. Wow. It's pretty crazy, this question. All right, you just need to expand the bracket here to get a final answer. I hope I don't need to use the quadratic factorization to factorize this one here. Okay, let's see. 9x squared minus 5x. All right. All right, so at the end, we have 12x squared. All right, minus 26x. Oh, gosh, minus 26x. Is that 26? Minus 3, minus 5 is minus 6, minus 8. And minus 18, minus 26. Yep. And plus 10. Plus 10. Okay. All right, let's factorize the 2 out from the last factor. So that gives us 6x squared minus 13x plus 5. Okay. Well, you can further factorize this quadratic trinomials. Use the cross method. All right, so that gives you 1 and 5. Negative, negative. Yep, that gives you 13. All right, so the final answer is 2x to the power 4, x minus 1 to the power 3, x minus 2 to the power 2, 2x minus 1, 3x minus 5. And that becomes the final answer for the derivative of that question there. Okay, I hope I did everything correct. Please let me know if it's not right, but that is how you supposed to do with the product rule when you have 3 products or 3 factors that multiply together. If you do have like 4, same method apply. You group 2 at a time and you perform the product rules several times until you get a final answer. Okay, that's all for this exercise. Let me know if you have any questions. Thank you.